All right, so we're recording. Hi, friends. Cluster add-ons meeting. It is April 13th. We got our normal Tuesday time slot. Got a bunch of cool friends joining us from various companies, as always. A couple of things on the agenda. Anybody else have anything they wanted to speak up on before Evan starts to get into? Oh, we had an action item from last week, I guess. Justin said that you were going to follow up on project submission to CNCF, and then I think Evan, you ended up doing some of that for the GSOC stuff, right?
Yep, everything's submitted and accepted. I still have a tab open to read through all the mentorship docs, but I think we're good for now. And then sometime in the next couple of weeks, the student selection happens.
Yeah, I would imagine that we're still quite ahead of schedule on that, or at least we're ahead of the ball, not trailing on deadlines and that kind of thing. Cool. Well, yeah, I DM'd you about that. I'm happy to help out with any of the mentoring stuff. If you need a formal co-mentor, please just ask. And
yeah, I mean, I would appreciate that, because this is I know that you've done it before. I have not, so I'd be looking for help there. I was also thinking we might want to reach out to SIG Node and see if someone there can help with this project, because it really touches a lot of node issues.
Okay, cool. Yeah, I will. I don't know how to add myself as a co-mentor per se, because we already have the PR and the CNCF repo merged, right? I guess I could just ask Ihor.
I think we can just update the PR. I'm happy to do that, or not the PR,
Okay.
I guess the document.
Yeah, I mean, I suppose since you have a branch open for it already, if you just want to add my name, then I'll hack it.
Sounds good.
Cool. And then how shall we reach out to the SIG Node folks? Should we just drop the proposal in their channel and ask them to say hi? Maybe?
That could be a good place to start, or we can look up their meeting schedule and see if there's a meeting we could drop in on and see what they have to say. It would be good maybe to get feedback of, like, we would never accept anything along these lines ahead of time, if that's something that they had.
Cool. I put in an action item to make sure that we don't lose that. Sweet. That's pretty good on GSOC stuff. Justin, I see you have preempted our agenda for a update on COPS.
Yeah, I just wanted to slot in a 30-second update, because like it will take 30 seconds, which is
timer is starting now.
Good. We have got tentative agreement to merge cluster add-ons behind a feature flag into our next version of KOps. So in the next couple of weeks, we should be cutting that branch, and then it will go into master branch, and we should actually start to see progress there. So it's been a long wait, and thank you to everyone that's done lots of stuff, and hopefully we will start to get it in and start to have that going into KOps.
Brilliant, brilliant. That's super cool. All right. And also a very succinct update. I think you still got another 15 seconds if you'd like to keep talking. Yeah, cool. Sweet. Well, that's GSOC and awesome news from the COPS side of things. Hopefully the OCI packaging stuff that we'll also be keeping a focus on in the coming months will continue to benefit the effort on the COPS side as well. Sweet. I guess on that topic, Evan, did you want to talk a little bit about Ruckpack? I was looking at some of these design docs last week, but feel free to take the floor. I think we have plenty of time right now.
If we have time, I made some slides for one of the operator framework calls. I'm happy to go through those if there's interest here.
I imagine that would be super helpful for other people to get context.
I cannot share my screen.
I can probably fix that. Security. Allow participants to share screen. All right, you should be good.
Ah, perfect. I don't remember how much we talked about this last time, but I'll just assume we all don't know anything about it. So this is a sort of an offshoot of work that we've done in an operator framework when we were looking at where we want to take operator framework in general and OLM in particular. And one of the things we wanted to do is find some of the common issues we've had in the past and try and isolate those into something that addresses those needs. So RuckPack is about getting content onto clusters and packaging content. A lot of the same things that we talk about with, transmitting manifests and OCI images. It's the same space, but sort of separated from a lot of the other things that operator framework is normally concerned with. So that's why it could be potentially something that we're interested in this context. I think that most folks on this call are probably familiar with all of these concepts, but I'm just going to quickly go back over the interesting parts of them. One of the things that we wanted to do is we're basically talking about writing a new controller with a new API to serve some of these needs. And we wanted to make it really unsurprising for people that use Kubernetes. And so we're trying to take inspiration from several other things like pods and images, persistent volumes, and CSRs, and specifically certain aspects of them. So pods and images, an image is a reference to an external runnable image, and then a pod says how that image should be instantiated on the cluster and run as a pod. There's no actual resource in Kubernetes for images. That's all just managed the node layer by kubelet and all that jazz. But as a concept, an image is there, and as a concept, pod makes that image exist and be active to some definition of active. And persistent volumes, right? They reference a storage class by name. So we're just looking at patterns that we want to reuse. So a persistent volume references a storage class by name. Storage class corresponds to some provisioner that's been installed in the cluster and configures it. And any persistent volume and persistent volume claim that references that storage class is managed by the provisioner that owns that storage class. So I have an example here. This provisioner is a unique ID for the AWS EBS provisioner. It manages any persistent volume or any persistent volume claim that has a reference to any storage class that says this provisioner. And the parameters that go into a storage class are specific to the provisioner. So we're going to try and reuse some of these concepts for RuckPack as well. And then the final thing that we want to try and reuse is the CSR approval process, which is relatively straightforward. You create a certificate signing request, and if it has this approved condition, the CSR controller will output the result of the CSR somewhere for you to use. This is the thing that's nice about this, and the thing that we like for RuckPack is that you can either have controllers that automatically approve things based on some criteria, or you can have a user go in with kubectl certificate approve, manually approve it, and that's something that you get to decide via policy and the way you configure your cluster. So those are those three big things that we're trying to take advantage of. And so RuckPack is trying to generalize the idea of pod and image to arbitrary artifacts. So we're no longer talking about runnable images, we're talking about content. And we're no longer talking about running a pod, we're talking about making content active, whatever that means. And because we don't always know what it means to make a thing active or what it means to unpack a non-runnable image, we want this to be pluggable in the same way that storage classes are pluggable for persistent volumes. And this is maybe more driven by some operator framework needs, but we know that it's useful to have gating around what can happen in the cluster based on that. So making it policy driven and automatable in the same way that CSRs are would be really valuable as well. So the first thing is we have the concept of a bundle. This is an API, so it's a little bit separate from the bundle cap, but the idea is that it's an image, but for non-runnable or even non-OCI artifacts. Like I said, the content could be made available to the cluster, and then we have enough use cases in operator framework, at least, that we know there's some value in having it be either a local or a remote reference, whatever that means. So here's the sort of strawman bundle API that we're looking at. You would have a storage class, and this corresponds to your provisioner. The examples here are all operator framework bundles, but that's just specific to how we are looking to use it. So here's a reference to an operator bundle, and there would be some operator provisioner in the cluster that understands what OLM bundles look like, understands how to unpack them. And the bundle API just makes the contents available. So this corresponds to the non-existent image API in Kubernetes. There's no real need for it because there's only one way that you unpack a runnable image, and that's you make the file system available to whatever your runtime is. But that's not the case for our bundles because we don't know how to unpack all bundles the same way. And so the idea is that the provisioner pulls this content and makes it available, whatever that means. In this case, we're saying, it'll list out maybe this is an aggregated API server and I can query it for sub-objects. Maybe it has references to config maps or volumes that contain content that other things in a cluster can then read from. So they can use the bundle API as a pointer to the content that they care about. And then here's an example of how you could use this as a local reference. If your ref is a file, then you can mount in whatever you want. And then again, the provisioner would decide what to do with that information. So the next layer
and then just a question on the local ref thing. So that's actually referencing like a file on the node itself, or on what?
This is again, it's all provisioner specific, but this is a file location within yeah, you know what? That's a good question. The idea is basically that if you take this content and pretend that it's remote, but it's available here. So presumably this would correspond to some pod that's running that can do the unpacking somehow.
I see. So whatever is implementing the something class, bundle class.
Yeah, whatever the provisioner is would decide the semantics of how that works.
To interpret that ref. Yeah. Okay.
But cool. I didn't think about the fact that that's pretty unclear. So thank you for pointing that out.
Yeah, it certainly could make some sense for it to come from like the node file system, but it just has to come from some like group of nodes that does unpacking or something like that. Cool.
Or okay. if this is a volume mount of a config map, we could create a pod that has a volume mount with a config map and have that pod do whatever this unpack stuff is.
Oh, I see.
But it's not really
like this is like whatever that provisioner is would also use the volume mount and then could use that file ref or something.
Right.
Yeah.
That's just an example of how we might use it.
Yeah, although in this example, you'd probably address the config map directly instead of like some file on a system.
Yeah, okay, that's fair.
Cool. Thanks.
Yeah, that's a good point too. This could just be like config map and you don't need a volume. That's good feedback. I guess I should also say none of this is implemented. This is just a design. And so if anyone on the call is interested in collaborating on the design and the implementation, we're totally open to that. Sounds like you have good feedback already. So the next thing up is the instance, which is sort of our pod idea. So this is the contents on the cluster. Now make it quote unquote active. And again, this is provisioner specific. For OLM and operator framework, we have an idea of what that means. That means basically taking the manifests that are in this manifest bundle and applying them to the cluster. It also means in the case of operator framework, doing any pivoting of resources between old and new versions and that sort of thing. And the thing that's interesting about that is that because we have the bundle objects on the cluster separate from the instance objects on the cluster, the provisioner has the context that it needs to do any sort of pivoting like that if it is required for the type of bundles that you're using. It might not be. So this lets you find old and new versions of the bundles. You can think of it almost like deployment managing replica sets or something like that. And then all it needs is a reference to the new bundle, because that will point to a bundle object on the cluster. But then if you're just interacting with an instance, much like you can create a pod, right, without creating an image object because there isn't one, you can also just give a spec of a bundle, and this will create the bundle, give it a name, and make it active via the instance API according to the provisioner in the provisioner class. So you can see the class is here for the bundle.
So instances of bundles, is the bundle spec intended to be used independently of instance, or is it only used as a template for instance?
It is used as a data source for instance.
Okay. How come there's a bundle spec in the instance object? Because that's
it's purely so that you can do it all in one step. I can do like a single API transaction that creates instance. You could get rid of this entirely, and you'd have all the same semantics. It would just be that now, if I wanted to create an instance of the thing, I have to first create a bundle, and then I have to create an instance. And we think that that's probably a common enough thing that, much like it's valuable to embed a pod spec, it might be useful to embed a bundle spec. Yeah. Anyway.
I think the instances of pod specs being embedded in an API is usually when it's used as a template to create like multiple pods. We did copy that pattern for Helm controller inside of Flux, and where it's only producing a single chart, a chart template. So that's very similar to this. But it's also super confusing. So just might want to look at if that's super justified, because you can, in a single apply, you can already specify multiple objects.
That's fair. You can't do it in a single FTD transaction, so you can't guarantee that a controller sees both changes at the same time. I don't know that that's important for this. I don't think it is. I think we could probably safely delete this section and be okay.
Yeah, it would be, you just probably would want to really define what the behavior is if the spec is not defined, because like a pod template for a deployment is not necessarily optional, right?
That's fair.
But yeah, it could go a couple of ways. If you want more feedback on just that specific thing, we're having problems with it in Helm controller.
No, that's really good feedback. And like I said, the idea is to be not surprising. So if this is surprising, that's probably a good indication that we should rethink that part. The last thing I'll point out here, I think I have another slide somewhere for it, but this is the approved condition. And this would be a thing that a provisioner would choose whether or not to require or respect. But in the case of a manifest bundle, especially operator manifests can have a pretty high privileged things in them. And so you might want to write something that, auto approves based on what's been approved before, never auto approves and requires someone to go in and review the manifest and type, kubectl approve. I guess the point is that this mechanism lets us delegate policy to things that are good at policy.
And so would the condition kind of be preloaded by the provisioner then?
Yeah, I mean, so I think if provisioners work the way, sort of imagining, then provisioners would by default not do anything with an instance unless it has the approved condition. And then you would, if you want something to be approved automatically, you just write a controller that approves all instances or approves all instances with a particular class, or you could ship an approval plugin with your provisioner and then the provisioner class that you're using defines what the approval policy is, all that jazz.
And since it's a status field, it can't normally be written by a client, right? Is that the idea?
Right. But I think we do want a manual client flow for that. I think that makes a lot of sense, especially for manifest bundles.
I'm wondering, like, from a GitOps perspective, if being able to already just mark something as status condition inside the repository is possible or desirable. That's interesting.
If you're doing something with GitOps, you might just decide that any content coming from your Git source is, auto approved, and write a controller that does that.
Yeah, and you could actually write a controller that does that via labels or something. But it's a little hard to imagine how that could be, like what the security ramifications of it are. Interesting. Cool. Okay, I'm following still.
That's a good sign. We're not way off. I don't know what I'm trying to say. Provisioners, I'll just keep going. Controllers that read and write the bundle and instance. You can configure them just like storage class provisioners. They have some, provisioner specific configuration language that they understand. So we expect this to be pretty limited for most of them. They mostly you'd probably just have a provisioner for a certain class of bundles, and then maybe there's a couple flags you can set for your storage for your provisioner classes. And then just like storage class, we want them to have a cluster unique identifier so that we can know which provisioner is supposed to be managing which bundles and instances. This is not a super useful example because I didn't think of a good example of parameters, but there'd be some ID here. You can stamp out some classes and then set parameters on your provisioner.
With the parameters for the provisioner, it just kind of controls like the provisioner's like global environment or something, right? But
yeah,
then,
it could be. I think, one good example would just be if your provisioner ships with some approval policy stuff by default, right? Like one of the ones we've talked about for operator framework is if the next version of a bundle doesn't contain higher permissions than the previous version, then it's approved, right? You only have to review it if the permissions are expanding in scope. And that might be just a flag on the provisioner class, and you say, by default, all my bundles are approved in this mode, but if you're running on a cluster with very restrictive permissions or very loose permissions, you could change that setting.
Are instance parameters a thing?
They could be. I don't think we've seen, I'm not sure that we've seen a good use case for them that wouldn't be covered by provisioner class parameters. Or are you saying, maybe what do you mean by instance parameters? Maybe that's a better way to say it.
So what I'm thinking is, like, say provisioner classes like customize apply. Then I could see provisioner class parameters for customize apply be something like load restrictor or enable these customized plugins. But then the instance parameters would be something like, here is my like pod identity label, or for this particular add-on or this particular bundle, or I want to turn the ingress on or something like that. Options like for that particular bundle.
I don't know, we've talked a ton about those use cases. I think they're interesting, but one of the ways I thought we could deal with some of that is this, the bundle API refs is a list. So especially for like customized things where you think about multiple sets of data, sometimes if you could just have, again, like a ref to some a config map that has some of your settings like that in addition to your base or whatever.
Yeah. Cool.
Yeah,
that just makes sense. That works very well for something like customized overlays. I guess if, say, you had a Helm install provisioner class, then there would be options for the provisioner class, and then for the Helm, bundle release, then you could ref like a values file from config map or something, and that could be your indirection. Cool. Okay.
Yeah, absolutely. Yeah, and that's one of the ones we're interested in, just because a lot of people package operators for for Helm.
Yeah.
So it's nice to be able to like pull them into the fold if we want to. Let's see, I think add a couple extra slides. I don't know that this is that important to go over. This is just kind of some like details of some of the security implications of having these APIs that can do this sort of thing in your cluster. So if you edit the spec of a bundle, or sorry, if you edit the spec of an instance, then probably its approval goes away, things like that. And you might want some restrictions around who can use what provisioner classes and things like that. But I don't know that all of that is overly critical for the general overview.
I would urge you, if you're thinking about the provisioner class, to this use case of like building APIs that expand arbitrary bundles of other API groups. It has a peculiarity with RBAC where the thing that provisions the bundle should have some precise identity. And that identity should usually be either like namespace scoped or bundle scoped. Does that make sense, Evan? You want to be able to role bind against the thing that applies the bundle.
Versus basically having a kube admin service account that can do all of this. Is that what you're saying? Is that what you're contrasting?
Yeah, I mean, I would imagine that if you're interested in things like approval flows and that kind of stuff, that an administrator account or the ability to say that like this account can use a particular provisioner class is not enough. Because the provisioner class needs to have some set of roles or cluster roles bound to it specifically. And it's usually based off of the workload that you're applying, not the way that you unpack the workload. So, or the bundle in this case. So like if you are installing a bundle from say some slightly upstream location, and say you have like a Fembear policy where you're like constantly want to apply that thing, you usually want the role to be kind of specific to that thing. Like, oh, I only want this to modify this type of custom resource and services. And so that way you can safely kind of accept updates from that location without like knowing that it's not going to create pods in your cluster. And that's not based off of the provisioner, which is like, I'm using Kustomize, or I'm using Helm, or I'm using Casenet or whatever. It's based off of the fact that that workload comes from that place. So you assign the identity and the role binding, to the namespace that owns the thing or to the workload itself.
Yeah, that makes sense. And if there's any issue with unpacking, you would just see like, the service account that you used or the user that you use doesn't have the permission to unpack the content or to apply the content.
Yeah, the builds should be it should be separated in status and even maybe in the API from like the concept of applying those things to the cluster or whatever. Whether you do that like inside the provisioner class or not, like there should be a separation of the two ideas. But yeah, the part that actually does the reconciliation to the Kubernetes API or any garbage collection or health checks or whatever, like that thing should be scoped to a particular role binded identity.
Yeah, yep.
It's kind of hard to do, but you should be able to do it on the provisioner class, maybe, if you just pick like, if you really want to read into this, I wrote a impersonation-based multi-tenancy proposal for Flux. It's on the Flux 2 repo, 582. it's really, it's about as succinct as you can be with the detail that's necessary. You could probably review it in like 45 minutes.
Yeah, I will check that out. That's good feedback. Thank you. We do something similar in OLM where I guess it's opt-in, but you can pick a service account that all OLM operations run under for a given set of namespaces, but without using the impersonation APIs, which I think is more or less what you're saying we should be doing here. Although one thing that's kind of interesting to me is that it almost seems like there's two layers where you might want like default service account for a provisioner class. You know, like none of my, I don't know, Helm charts are allowed to create CRDs or something like that. And then you might want something more specific for, like you said, for namespaces or for specific users or something like that.
Yeah, I think that's usually the job of like pre-assigned roles and cluster role, or like the cluster roles in a cluster are used to kind of provide bucketed default rules. And then role bindings are very succinct, right? Where it's just like, this is the principal, this is the set of roles or cluster roles that they get. And whether it's at the cluster level or at the namespace level. So like you can role bind within a namespace against the cluster role admin, right? And then give whatever is in that namespace access to a reasonable set of resources. And then if you give them cluster admin instead, inside of that namespace, they can delete their own namespace. You know? Which is weird verbiage, but that's how it works.
Right.
So like with Flux, we were looking at adding cluster roles for like source admin, Helm admin, that kind of thing, that you could just precisely role bind against without knowing all of the inner details. So that you don't have to be like, a lot of times, like when people see RBAC, they think of every single object because they're used to seeing like an RBAC YAML from some project, which like owns every single part of it. But usually these, like, they're pretty disjoint sections where you can like just use the bits and pieces of the decision that you're actually trying to make. Yeah, as soon as you get into like defaulting, and a default SA makes sense, like if that's user configurable to what that is. But if it's not granularly configurable, then like you might as well not be super concerned about like policy per object and all that stuff, because that just means like all of the objects will reconcile with the same administrator permissions, which is pretty, it just taints the security model of the cluster like pretty badly.
Yeah, that's true for sure. I guess one of the things that maybe is not as relevant for RUCPAC in general, but is relevant for operators, is that they often need small escalations of privilege to install, and then you don't want people to continue using that privilege. So that was some of the motivation for the approval workflows. Is like normally, you know, you don't want a user, you want a user to be able to say, hey, I want to install this, but whether or not it can be approved to be installed is not necessarily their decision. And that's kind of where that came from, is, well, if it's not their decision, then someone else has to come and stamp it for approval, and that might be an automated process, or it might be an administrator who just adds the flag to it.
Yeah, and Nick mentions in the chat that there's a difference between permissions that are necessary for installation of software versus the permissions that the software or content like runs for its lifetime, which is certainly true. But just that, like, depending on where the software comes from or what type of software it is, like you would probably want different installation permissions themselves, which is what the provisioner class is. Cool. Sounds good. Sorry, I don't want to slow you down too much, and I
That's
know
okay.
that we have other things to get to, but
Yeah, no, that's pretty much it. I didn't mean to take up the whole time. There's more pieces to this. Like this is something we've been talking about in Operator Framework for a while. There are other sort of layers, but this is the first one and the one that I thought would be most relevant to this crowd. So if you're interested in any of the other stuff, you can come to the Operator Framework meetings. And then if anything there comes up that might be valuable here too, we can definitely bring that back. But I think that this is the first thing.
I'm
When are they?
pretty keenly. Oh,
Sorry,
okay.
go ahead.
Continue. When are the meetings?
How about I'll find the calendar and drop it. And
Cool.
they're on Thursdays, but it's every other Thursday, and one Thursday has it in the morning, and the next Thursday has it in the afternoon.
I think I just wanted to add real quick. I think we're kind of envisioning this as like not Operator Framework specific, but as like a separate project that like Operator Framework can use. I don't know if Evan mentioned that earlier, but I think that distinction is kind of important.
Certainly, it seems like a generic mechanism. I think that there's a lot of value in that in what you've proposed, and that the API shape is quite different from things like Argo and Flux. I'd encourage you, if you haven't looked at those projects, to at least examine what lessons can be learned from those APIs. But yeah, the goal of Flux is to be a generically extensible project that can be integrated into many third-party systems. And there are a lot of components here that do what you're looking for. So I'd be curious on what kind of role Flux could play if we, had good integration with these OCI bundles. I'm very keenly interested on getting good interop between all of the artifacts and that kind of stuff, knowing how to unpack them, providing extensibility for when people want to do fun things with their artifacts that aren't supported in Flux. That all of those things are super interesting. The approval workflow, we're looking at adding gates to the API. There's already other ways of doing that with dependencies as well. The RBAC portion of it is well handled and is being improved already. So there's a lot of bits in here where it's at least we'll be happy to help you learn the lessons from there, but maybe consider using source controller or some of the other applied controllers to do that sort of stuff.
Yeah, I think we can definitely take a closer look at Flux. I guess having not used it personally, my impression was that it was serving different needs. But if you're saying that it's very much in the same space, we can definitely take a closer look at it.
Yeah, what we've done in the Flux project of refactoring into Flux 2, which we're working on making generally available, we already recommend people just use Flux 2, not Flux 1, is that the ideas have been decoupled into primitive APIs. So if you only want to pull a source into a cluster, you can do that. You can say pull a bucket or a Helm repository or a Git repo into a cluster internal cache, and ignore things from it and start doing stuff on it and make it available inside the cluster. That's the sources APIs. And then separately, if you want to reference one of those sources and then reconcile some of the things from inside those sources into the cluster's API server, that's a separate API object. And decoupling those things has made Flux much more modular. We have an SDK guide. It's all controller runtime based. So I could see these Ruckpack use cases fitting in or extending the Flux APIs, absolutely. you could use some of the existing maintenance and infrastructure components from the Flux project to build a purpose-built system, or use Flux generally to serve this use case. Especially when we add the OCI stuff, which still needs to be proposed before it's implemented. That's kind of my main bullet point here, is like, how should this stuff work, you know, if we were to propose and implement it in Flux.
Yeah, I think I think I just need to take a closer look. Like, for context from the operator framework side, we would want to take a lot of what OLM does today and just have it be a provisioner for bundles that happen to be the types of OLM specific bundles we support today. And that includes a lot of really specific logic around like when CRD updates are allowed, you know, when we roll out different changes. And so I didn't think that was a thing that we would easily be able to plug into an existing thing like Flux. But if you think that's worth looking at, we can definitely take a look.
Yeah, I think if we were to compose that with something like the release gates, then you could get that sort of behavior. But yeah, at a minimum, there are things in the API that could just probably help influence some of the decisions. I think some of the inspiration on the core API types is something that we've really looked to do when modeling the Flux APIs. It looks like you're trying to take that approach as well with the Ruckpack stuff. So there's really good crossover. We didn't do a like provisioner class style thing, but we do a secret ref style stuff with sources and alerts, that sort of thing. And then for like cross namespace interactions and stuff, the proposed restrictions will be coming natively from RBAC. Yeah. Bundle stuff in Flux. I guess that's a good segue. I'm keen to see how the provisioner bits in Ruckpack can be made to be more generic. Perhaps we can take some of those design decisions and also implement them in Flux. Maybe the provisioners could be cross-compatible. But yeah, for bundle stuff, you know, there's all of these OCI formats. There's the Helm tarballs inside of the OCI charts. We've got the bundle kep. We've got the image package stuff from the Carvel team. And then people are just pushing all kinds of stuff to OCI registries now, like the Tinkerbell OSS project from Packet is pushing disk images like ext4 file systems up to OCI all of a sudden. It's just like experimental right now. So lots of weird things happening there. But you have these blobs inside of the OCI descriptors, and they have media types. And I was figuring, like, is there a useful generic way, you know, potentially for us to unpack these images onto a file system? This basically gets into kind of what you were talking about, Evan, with like having a provisioner that's like fairly generic. So I'm talking about the source controller part, not necessarily the part of the provisioner that applies resources to the cluster and picks paths and builds things, but just the idea of like what's in the bundle or the artifact and like how do you represent it on the file system to begin with. The fetching and unpacking part seems to be a peculiar problem when we have all of these proposed formats. Any thoughts from folks there?
I mean, definitely my feeling is that long-term, we would like to get kubelet support for pulling OCI artifacts, not because, mostly just because of the cluster configuration challenges that you have without that. All of your non-runnable images will be second-class citizens in a cluster if we don't go that route. You'll have separate config. You might be talking to the same exact registry, or the same exact namespace in a registry, but you'll have to have separate configuration for it, which
Like
sounds like a bad
configuration,
UX.
are you talking about like auth, or what
It
exactly
could
are you
be
talking
auth,
about?
it could be like proxies, it could be you have custom certs for your private registry that you're talking to, which you have to configure once for all your nodes to talk to, so the kubelet can pull the images, or mirror configuration. That's another one, if you have configured different mirrors for things.
That's
And then you'll have to
interesting.
configure it again for your non-runnable artifacts, talking to the same exact registries, the same cluster.
Some of those infrastructure challenges can be a little bit problematic, because they break the namespacing model of pull secrets. Because I know like pull secrets basically allow you to have a Docker config JSON. And anything that doesn't really fit into that object kind of has to be done at the infrastructure level. But as soon as you start modifying the way that a kubelet talks to the registry, that's like for the whole cluster, or for any pods that land on that node, rather. It's usually done for every kubelet in the cluster, but I guess you could have different node groups talk to different registries or have different authentication credentials. But yeah, if you want to like prevent some other namespace from, reading your images, that's just not doable at the kubelet level per se, without other abstractions like isolating node pools to a particular namespace.
Yeah, I guess if the kubelet understood that, though, that understood OCI artifacts, then you could just use regular, quote unquote, regular pull secrets for your artifacts too, right? And then the kubelet would do unioning whatever the pull secret creds are with whatever the node creds are. And then it gets to make decisions around what mirrors it knows about based on its configuration, right?
That's interesting. I don't know if I'm convinced that the kubelet is the right place to store that configuration. I do agree that there's a challenge in like centrally representing the config in a way that the kubelet can use. I'm not sure if just because the config, is canonically configured on the kubelet right now, that it's the right place for it, is I guess what I'm saying.
Yeah, I think that's totally fair. I didn't mean to be that prescriptive with the solution, but yeah, the problem is the configuration sharing, and if there's a solution to that.
Yeah, that's a good issue to think about, because like having to configure like every kubelet on the cluster just so you can talk to your config registry, when that can be done like on a single controller or like with a couple of API objects like in the cluster, seems like a really high cost to pay. Like I can't just walk up to a cluster now and then say, okay, I want to do registry ops, right? Like now I have to go configure the cluster kubelets to be integrated with my config registry, as opposed to doing it on the one workload, right, that fetches the things.
I guess I'm saying you should be able to do both is the problem. And right now, let's say we build a controller that pulls OCI artifacts and applies them to a cluster. You'll have to hand that thing some credentials in a secret or something like that. But if your cluster is being run by infrastructure owners that have configured a policy that everything has to go through a central proxy, or that all Docker registry traffic needs to be, talking to some particular registry with a particular key, with a particular cert, then now you also have to configure your OCI puller with the certs that maybe you as a cluster consumer don't even have access to because it's been abstracted away from you in the infrastructure.
Yeah,
So that's the thing that's tricky for us.
I imagine if you at that point you could whatever like component, say it's source controller, unflux, you could configure those same things on the source controller pod by doing things like host volume mounts for the certs and config.
You could, but all of that configuration is CRI specific, right? That's there's no standard for it. I think practically
Yes.
there's two standards. There's the Dockery and Red Hatty, I guess.
Yeah, I
There
think
might be more,
Docker,
I don't know.
Containerd, Cryo, right, are the main runtimes, and they all
Yep.
have different config, right?
I think they do. I mean, I can't remember if Docker and Containerd are the same config now. They might be,
that'd be nice. Yeah.
but there's at least two.
Yeah, I mean, if we had a package that targeted those two, I mean, you'd certainly be well beyond the 80% use case for cluster runtimes, right? We kind of have this same problem right now with webhooks from registries. They don't all look the same. And that's something that the Microsoft folks brought up. Just all of these individual implementations, like the stuff that happens outside of the standard. It's like we still need some standard way of having interop for all of those config. So like events for like image push, right, is completely non-standard across all of the image registries, and we almost have that same problem for the configuration of like mirrors and proxies.
The thing that is annoying about all this is that that's one of the big advantages of using OCI is that we have a bunch of infrastructure already for distributing this content with these standard APIs. But now we can't configure our clients to use the same configuration just within a single cluster.
I can definitely understand the appeal of like reaching for the kubelet, but it's kind of, in some ways, I don't see the abstraction as complete enough. Like you can get the kubelet to go pull the thing, but then we have to add stuff to it in order to support these use cases. Is what I'm like kind of feeling out. That almost feels like a separate component. Now we have this kind of need to maybe just break out the config sharing portion of it instead. Yeah, we should keep talking about this at a future time.
Sounds good.
I know we're running. I'm happy to keep talking a little bit. If I'm not sure if you have to run, Evan, but I just don't want to hold people here for too long. We're at time block.
Unfortunately, I do have to run, so maybe I'll hold it
for
next time.
Yeah, great. Tough problems. Cool. Project interop. Lots of stuff. GSOC. We did some stuff today. Thanks so much for doing the presentation on Ruppack. That stuff is really quite a good design for just something that's been whipped up.
Thanks. Yeah, I really appreciate the feedback that you had for it.
Yeah, let us know if the folks over on the Flux project, particularly the other 3 maintainers, are brilliant, and they're thinking about these kinds of problems all the time. So we're happy to help kind of point folks in the right direction with these APIs.
And maybe we can get like a shared Slack channel going or something.
Sweet. All right, I guess I'm going to stop the recording, friends. Our meeting notes are here. I'll post it up to YouTube as well. Anyone else have any parting comments? I know Evan and I filled a lot of space in this meeting. Cool. Well, take care of yourselves, everyone. We'll see each other in 2 weeks at a minimum.
Yeah.